Alright, so I wasn't able to make the class last time because of an illness, and I really hated that because we do have a lot of stuff still to do. We were talking about ellipses, and one of the things that we hadn't gotten to yet was the reflective property of an ellipse. The idea is if you have an ellipse like I have here, and you take any beam emanating from one of the foci, when it hits off the side of the ellipse, and this works whether it's a two-dimensional ellipse or if you take that ellipse and rotate it to make a solid, when it hits off that side, it turns out it will reflect directly towards the other focus. And so that's the reflective property of an ellipse. Now, it has several uses. We can construct things in the shape of various ellipses. Using this reflective property, you can talk about something called a whispering gallery, and talk about constructing an ellipse to build what's called a whispering gallery. It's actually an ellipse that's kind of been cut in half. It's an elliptical half, but it's been sliced across its major axes. You can also use ellipses to talk about constructing arches. You might construct certain running tracks in the shape of an ellipse, various things like that for an ellipse. So here, in this problem, we're looking at a whispering gallery. We're told that Jim, who is standing at one focus of the whispering gallery, happens to be 6 feet from the wall. His friend standing at the other focus is 100 feet away. We'd like to figure out the total length of the whispering gallery and how high is its elliptical ceiling at the center. So we begin by drawing a picture and also keeping in mind that we would set our ellipse up so the center is at 0, 0 to make the equation a little easier if we need to use the equation. Actually, in this problem, we just need to remember that A would be the horizontal width, since we are going to make that longer, and B would be the vertical height in this formula. So what we do know is that the foci are 100 feet apart. That means that each foci would be 50 feet from the center, and so we know that C will be equal to 50. We also know that the edge of the wall is just 6 feet away from him, meaning that the gap between the foci and the vertices is only 6 feet. And so from that we know that C is 50 feet from the center, the foci is 50 feet from the center, the vertex is 56 feet. That's the same on both sides, by the way. So the first question they asked, what's the length of the whispering gallery along its longest part? That would be precisely 56 feet times 2, which would be 112. The other question is, how high is the elliptical ceiling at its center? So in other words, we want to find the B value. So we know that C squared, the focal length, is equal to A squared minus B squared. So from that we can solve for B squared. We get B squared is equal to A squared minus C squared, which would be 636. And so B is 25.2, and so that is the height of our whispering gallery. So we actually never had to write the actual equation out in this particular problem because the stuff we wanted were the pieces of that equation. Okay, so we'll continue in another video, look at maybe another example with an ellipse, and then we're going to get into some hyperbolas.